As we said, there are two parts which we are going to talk about today. So first part is very, very basic machine learning concepts. And we have got some very young folks joining us today, which is pretty good. I think that raises the bar pretty high. He'll be the sharpest, by the way. Young folks are pretty brilliant and bright these days. So let's see who answers the questions, in which we are going to ask questions in the second half. So be careful. Don't shame yourself. The bar is going to be tricky. So what is machine learning? What comes to your mind? Let's take some quick guesses, polls from people in the room, WebEx. What comes to your mind when we talk about machine learning? Intelligence, okay.
Might be machine
Learn, okay.
Finding the patterns in the data and
analyze the data and come up with a meaningful decision making.
Finding, analysis, all of that. Really good good answers. Anything from the chat? People online can put on the chat, or they can speak as well. So feel free to do that.
The machines using data.
Machines what?
Learning through data.
Learning through use of data. That's very true. So I think all of those are very good points. This is the official kind of definition. Machine learning is the method of teaching computers to predictions of some data. You folks covered that in some form or shape. So people who have not speaking, I think you have spoken already the answer, please mute yourself back. That will be helpful. So that's in general, but I don't like this kind of definitions. They're very boring, they're very wordy, and they don't give really the push which we need. What I really like to do is really take examples like this. Most of you are coming from IT background, some software, IT programming, right? How many? Let's do a quick raise of hand, right? Majority is from that. So you know what traditional programming is. So why don't we just take a few moments to contrast and compare machine learning with traditional programming. In traditional programming, what happens, we have something called as data. We have a data set, let's say it's simple data sets, 1, 2, 3, 4, simple, an array of 3, 4 digits, nothing that fancy over there. Now a good programmer is going to come in and write a program in any language, Python, Java, .NET, whatever he may like, and he would write a program, and that would program, let's say he's writing a program for a simple function, x square. He's just taking an input and just squaring it, right? Just making a square of that number. And his program works fine. Let's say it works it right, no errors and everything. It works fine, and it gives us the output. It gives 1 becomes 1, 2 becomes 4, 3 becomes 9, and so on and so forth, right? So that's kind of the pattern which it does. That's traditional programming, as simple as that. What is machine learning? It's very different from that. It starts with the similar kind of set of data. Let's say we have the same set of data, and then instead of writing a program, we actually have the output in front of us. The output. This is the data set we got, and this is the output which we got. What's happening there? What happened there suddenly? 1, 2 became 8. What's happening? Agree? Yeah? Great. Human minds are very sharp up to the number 5. 4 digits were there. Great. 5 digits were there. 20 digits were there probably. If we had million numbers over there, or even hundreds of numbers over there, human mind like backs off like quickly. And that's where the machines come into picture. And they deal with situation, they sniff through this data, go through the scenario, and they are the ones who is going to produce the formula. And that's what machine learning is about. It has the data and inputs, it has the outputs, and it takes that, sniffs through that, and comes with a formula or some kind of function. I'm doing it at a very high level. I mean, people who are knowing machine learning, they say, no, that's the problem. Just ignore that. Keep your mind at home for now. It's a very high level because we're just starting. I take baby steps and we'll go through, address all those complexities and corner cases. But in the simplest form, it's a cube. Now what do? Now the next number comes in, let's say 5, and we take that formula, apply that formula, and that becomes. When I start talking, I'm not choking. I want you guys to speak because in the evening, you're sleepy, you're coming tired. Let's keep the engagement level a little high. So that becomes 125. That's what machine learning keeps on doing. It looks for data, looks for pattern, it finds a formula or a pattern kind of a thing. It's mostly a formula, end of the day, mathematical formula and everything. We're not going to do much of mathematical things. So one thing which happens in these kind of machine learning programs, they immediately start with some statistics, formulas, and half of the crowd runs away within 5-10 minutes. we're not going to let you out. We're going to literally close the door. No, without doing that, we're going to keep it in such a way that it's not needed and we don't need to do the math. In fact, I'm going to teach you some tricks and tricks without doing any math. We're trying to solve a use case in the second half and solve some of the tips and questions which I'm going to do in the second half of the scene. So this is what I like. Compare machine learning to traditional programming. How does that thing? This is very simple to understand. A very simple example so that you ingrain it, and when somebody says machine learning, this kind of picture comes into your mind and you remember for hopefully a longer period of time. That's my intent. That's usually I try to do stories, examples, such a way to make life much easier. So that's machine learning. Examples. We hear it over and over again. The classic example is this, because if you take any book or anything, you'll definitely find an example for spam. Because as soon as everybody pretty much has an email, right? At least so far, I think future generations may not want email. They don't care about it, right? Texting is good enough. But now, right now, we have it. You create an email ID. You go to your inbox. You don't find any email the first time, but you go to the spam. Automatically, you have got some spam. That's the unfortunate truth, that some spams keep on coming continuously, you like it or not, from whatever kind of crazy sources. But what happened? You didn't do anything, and automatically somebody told that this is spam, and they figured it out. That's what has happened as a machine learning example. The Google server, the Outlook server has learned over a period of time and built that knowledge that this is spam and this is not, right? So it's learned this coming from so-and-so language, so-and-so reason, this is a spam folder. In fact, nowadays I've noticed, I think iPhone, when some scam email is coming, it says scam likely. Have you, anybody noted that? It's a great feature. And most of the 100% of the time I've seen that that's good. That is a scam. I think sometimes maybe this is a good number. No, it is a scam. So I think they have done a good, very simple thing. They have taken a repository of things, fed in the backend, and just applied to the software saying this comes in. Probably they're not guaranteeing you of this world. You don't have to guarantee anything. Be a weatherman. You say it's going to rain. It doesn't rain. It's okay. You don't lose your job. Because he said what? That detailed part was there was a 5% chance. There were 20% chance. That's what people ignore. People say it was going to rain, but that they always put a percentage. They don't guarantee anything. That's a prediction in this thing. So that's what Google is doing it. Apple is doing right now in the iPhones. That's what happens in the thing. But occasionally there is a spam which creeps in, right? You suddenly find in your inbox, and that's where you come in. And you help the machine to say, nope, this is spam. This is junk, block it next time onwards. And the machine learns from you. That is a small helping hand which you give to the machine. So that's one very classic example. There's tons and tons of examples. There is a lot of hype around machine learning, right? Everybody's talking about machine learning. Everybody is talking about different use cases and scenarios, which is happening, self-driving cars, fraud detection. Many of these have been there for quite some time. It's nothing new. In fact, we were talking in the beginning, and every time I get, at least whenever I do these sessions, at least few people who were like started this in 1980s and 90s when neural network and initial revolution of machine learning happened, and it did disappear suddenly. Nothing happened much, and those people are really mad about it. They spend a lot of time, energy, and a lot of people did, and spent a lot of energy into that. Is it going to happen again? Will machine learning go away, or this artificial intelligence? What do you guys think? You guys think it's going to stay for this time, or again a hard break event?
At this time, there is a tremendous, there is multiple technologies needed for kind of artificial intelligence, and they are all coming to fruition at this point. The big data capability, the compute power, the GPUs, and all those things are coming at the right time. So this is the time where it's a right time for the technology.
Anything for me to say? You said it all. No, it's perfectly great. So thanks for inspiring that, which is very true. In fact, it's already happening. How many of you have Alexa or Google Home at your home? Wow, that's a lot of person. It's more than half. Majority is having it. I have it at home as well. It's very common. And it's happening. It works. I mean, it doesn't say, oh, please repeat the contents or this accent or some kind of issue. It understands so many different variations of people with artificial intelligence. I have a 7-year-old and a 12-year-old. My 12-year-old, every night he looks, when the school is there, he'll ask Alexa, what is the weather tomorrow? And based on that, he will prepare his dress, whether short pants or full or jacket, he will keep his dress ready. They find unique uses. My younger one has stopped asking me questions. Dad doesn't know anything. He's dumb, which probably is. asking like, Alexa, all these questions, how far is Jupiter, which is the hottest planet, which is the coldest planet. Of course, I don't know all of that. My goodness, this WebEx is killing us. I'm going to continue for this group at least and let it happen what happens at the other end. Can't do much, sorry. WebEx is not cooperating today. So lots of uses already happening, and very much rightly so. It was combination of several things. It was combination of data being available, the bandwidth available, processing availability, which we have right now compared to what was years back. Years back, we had the algorithms, the logic was there, but there was no compute power. I mean, very simple example if I take is like if you have a surveillance camera. A surveillance camera has been for decades probably, right? They capture thing, a thief comes in, robs everything, waves the hand to the camera and leaves. And the cops can come in later point of time, look at it and see the thief waving hand. It's a very reactive thing. Actually today, the technology exists, the speed exists. It's not needed. People don't buy it because it's expensive at this point of time, but the capability exists that it can, in high security zones, to facial recognitions and everything, it can identify such activity. It can directly contact or intimate the cops or security people already, that technology. In fact, it's even scarier than that, that drones can fly and they can find wherever everybody is. They can track who is where every single point of time. I mean, how many of you have heard about Amazon Go? It's a web-based portal. And how many of you have heard about Amazon Go? It's now in Google. It's a cool shop, which a grocery outlet, which Amazon has started in Seattle, I think only yet. Basically, you go to a store, pick up a thing, and walk out. Just walk in and walk out. It will automatically charge you something. What is that? It's like detecting things, what is moving. It's connecting to your wallet, basically your card, which is attached to the app, and it's taking care of everything. So such technologies in real time do exist right now. So it's happening. There is no doubt in my mind. I'm pretty optimistic, and a lot of things happening in this space. And many of these forms, I think there's a few examples, speech recognition, the Alexas of the world, facial recognition, it's surprisingly so good. So too good sometimes. I mean, I got an intimation from Facebook like, oh, it seems like this photo is you. And I didn't tag. And do you want to tag yourself? And yes, it is me in one of the conferences. Somebody posted that image and it says like it's identified you over there. That was creepy. But I said, okay, it's happening. It is true. And that's what these cases are there. So all of these interesting pieces which really help really do much of the machine learning use cases. Now, this is a very, very interesting slide. It's a very fascinating slide to me, at least, and many people will find that once I explain what it is. How many of you have heard about Gartner as a company?
Hey, Raj, for some reason, we are not seeing the screen. Sorry.
Okay, you guys are back. So WebEx is having some problem. It's not, we are no longer connected to the meeting, and it's trying to reconnect. Problem. So I'm letting it do its thing. I'm going to switch Wi-Fi for a quick and see if that really helps. Usually it does, but I don't know. WebEx is performing pretty bad today. Back. So yeah, you must. People are talking about Gartner, right? So people are. I'm making it even. I'm not showing even the people in the room. What it is. So Gartner is a company which you have heard of Magic Quadrant most of the time. People have heard. So basically they say, oh, in the CRM space, Salesforce is the leader for last 5-8 years, or so and so forth. So that's very common, which it happens in this thing. But Gartner does many more things. One such thing it does is this is called as Gartner hype cycle. Every year it comes with this curve or this chart. The curve is pretty interesting. It doesn't change. It remains same. It's a very fascinating. I really, I mean, it's amusing to think about this curve. It happens to us over our life, over and over again, with things, with relationships, everything. We just go through a cycle. We think about, let's say, example, let's say iPhone 10. Oh, it's a great. The hype and the enthusiasm builds on top of it and just keeps building to the point it is shipped and it is coming. It reaches your hand and then there is a crash. And then you say, oh, it's not great. It cost me so much money. I even lost my home button. What is with that? And then you realize, okay, it's not that bad. It's still useful. There are a lot of good things. It has a better camera. I think realization comes. So this curve, we actually go over and over with our life continuously. So the curve remains same. So Gartner doesn't change that curve at all. It's back, but it's not letting me share again now. It doesn't think. Okay, I have to become presenter. And also I'm trying to record, so I think you will get the recording.
We are able to see that now. Thanks, Raj.
I know. I think, yeah. So, but I think some pieces got lost. I think so. Really sorry about that. So we're just starting with the initial pieces. I think if it hangs in through for the rest of the period, I think it's going to be all good. I think this is some background, useful background, but it's a good one. So I was talking about this Gartner hype cycle, and what it happens, the curve remains same. What Gartner plots is new emerging technologies. So anybody looking to think about where the kids should go for the next 5, 10 years, 15 years, this is a slide. If you are thinking about where your company should go, what you should be doing in your career, this is a slide. It's a very powerful slide which helps. And I'll explain because there's a lot going on there. The first part, the innovation trigger, is actually a space where one person in the garage is trying to do something crazy and create the next Google or Microsoft or Amazon, if you would think, those things. For example, there's something called 4D printing. We haven't even figured out 3D printing yet, right? And there's somebody figuring out 4D printing. So those are very early kind of startups thinkings which are happening. So these are most of the people haven't heard about this. As we progress up, we think what are familiar names. How about IoT? How many of you have heard about IoT? Pretty much everybody. Internet of Things, right? So everybody has heard about it. Blockchain, most of you, right? So that's also happening. So most of these pieces are already tackled as we go forward. Our good friend topic for today, if you notice that blue circle right in the top, the pinnacle of hype is machine learning, right there, right? And that's why we hear it everywhere. So you may be questioning like or thinking like your intuition or your perception is validated by Gartner for years, and it says yes, it is at the crazy peak hype which everybody, even the mattress shop says we use machine learning. Everybody's talking about machine learning these days. Think how many times you turn based on the mattress will change probably or something. So if you are trying to get into a VC funding or something, put machine learning AI, your chances are already up. It can hurt sometime down with as well. But the fact is, machine learning is on the peak of it. Is it good or bad? I think we were asking the question in the previous part, will it stay or not in a different form? I personally believe it's a good thing. With a lot of this attention and a lot of this investment, just lots of companies are putting huge investments, and it's going to get some really good products and outputs, which is happening. Our world, in 5-10 years, our kids are going to be saying like, really? You were driving? That's so unsafe. You guys drove? That was so bad. You used to type? Why do you need to type everything? Right? It is going to happen. Such things, maybe 5 years, 10 years down the line, driverless cars, everything, all of this is going to change. A lot of things are going to change, and we are the generation. Every generation sees a lot of change, but the pace has increased tremendously. The pace has increased. That's a challenge. That's a new thing. Eventually what happens, these things just pass through a cycle and reach to a state called plateau of productivity, which means no more innovative things. Microwave in this curve, some point of time. There was cars in this curve, some point of time. There was big data in this curve in 2010, 2012, right? Things pass and then they are not in the hype curve. It's a journey, and it's all good and useful thing. This is the same curve in 2017. I haven't been 2018 yet. It should be around the corner in weeks, or maybe it has come. I should go and look it up. But that's where this is. Machine learning still remains to be there in the peak. It's not changed spot a little bit. And deep learning has suddenly showed up, which is good for me. Because every time people used to come like, what about deep learning? Okay, there it is. I don't have to worry about it. I'm sure somewhere people are going to ask AI and all of the things, which is other pieces. Things have moved a little bit. If you see, blockchain has passed the curve. It has moved out of the hype and coming down. IoT still remains very much similar. There is also a color coding going on in terms of like below, if you know the legend, the light blue things mentioned 2 to 5 years, it will be in mainstream adoption, which is pretty much out of the curve. So, and you are already seeing machine learning happening in different forms and shape already. In driverless cars, it was already been piloted and tried in different places, but unfortunately there were a few accidents and that has taken a step back. So such things do happen, but I think this is pretty useful curve, which if you're looking for, search for Gartner's hype cycle, and you'll see this curve and you can go in detail. And I think I find it very fascinating, and some others might find it as well. Now with hype, all the big players, big companies are into this. They understand this is revolutionary. This is going to be a game changer. So we need to have our game up in the system and really get this going so that we can be partaking. For example, Amazon, to their Amazon Web Services, provides an offering called Amazon Machine Learning. This came in around the second half of 2015, and I was noticing the changes coming in very quickly. It was like a war. Within few weeks, literally within few weeks, if you notice, go back in date, you'll find Google came out and said, we are open sourcing our machine learning offering, which is called TensorFlow. TensorFlow, which they have been using internally for years. They just shared with the open source world. Which is Microsoft, came in late in this game, but they've done an awesome job. I think Satya Nadella has turned the company around to be a cloud company, and done a lot of amazing stuff in the space. I'm going to use that, if time permits, to do the demo, because I think that's the easiest in such an environment. It's a drag and drop tool. I won't write a single line of code, and we'll do something in machine learning that none of them offer at this point. So I think that's the only one. But I think more detail, you may have to do some other pieces, but I think for the demo, it's pretty good for our demo. The last one on this list is Spark. If you're coming from the big data space, you may have heard about Spark, which is the best processing engine which we have in the big data world. And it also has a library called machine learning. So if you're coming from the big data world or your company is using Hadoop or any kind of thing, they probably will be using Spark machine learning. So these are few of the offerings. There are many more. There are variations of others doing different forms. There is machine learning using Python. A lot of the Python libraries and Pandas and NumPy, the scikit-learn, all of that really play a very important play. This is the most common one because Python is so easy. People pick it up and start running with this very fast. So that's one. There is R. R is more of a statistical language, but has good bit of modeling and these pieces as well. So that is what R provides as well. There is Mahout. There is SAS. There are many other offerings. I just wanted to bring few so that you get a sense of it. What we do in our machine learning training program, we do a couple of them. Most of them, they touch one. We do definitely Python, and then we do also do Spark-based machine learning. So that's the combination in our training programs, what we do. We also touch Azure. So that's why we want to give you quite a few of different tastes. So that's all about the background. Now, everybody's coming up with some things. I think I just wanted to look at the big common ones, which most of the people already may have heard, but just to give a list of things. Yes, there's Dekeras, there is TensorFlow with some deep learning. There are variations of it, absolutely. Yeah. Now let's get to more of the concepts and everything. Do you want to take these chairs? So now let's get into the concept. When I say meaning that, pay attention, I'm going to ask these things. So I'm giving you hints that these are the questions which I'm going to ask. But let's get into the concept. As I said, you do not need to know anything about this, and I'm going to build slowly everything. And I try to give simple stories, examples that anybody can anything. If he can understand, today I'm very happy. He seems already happy. Supervised and unsupervised learning. These are two concepts which are first thing which somebody should pick it up to what is the meaning of things. We actually touched it already. When the machine, the spam filter, was finding it himself, that is more of a unsupervised learning. When you went and said, oh, this also is a spam, that's a supervised learning. You are helping the machine. You're supervising the machine. That's at a high level. But let's take a simple example. Now let's take an example. I have an example for, let's say we're trying to solve this problem. We have a huge basket of fruits, even let's say artificial fruits, that's fine, plastic fruits. And we have all these bananas and apples and everything in the huge basket. Our goal is to segregate them. Put all the bananas one side, put all the apples one side, nothing. Just do segregation of that, right? That's our goal. So to be able to do that, I'm going to call the most intelligent people on the planet and to help us. And they are kindergarten kids, right? They are the most fun, the most intelligent. Brain activity for them is like, right? If we keep that activity level, we are going to be much better than even machines probably. If we do, we stop after some period of time. We get too scared. So they are very fun. They would quickly come into this kind of activity, jump into all this thing. They're always eager to do activities. They will, within minutes and seconds, probably start segregating this. And they will be able to do this awesome way. Even if there is a yellow apple, there is a green apple, there is a small apple, there is a gala apple, just figure it out. There is not looking for a paper, a color sheet and saying, oh, this matches this color, this is an apple. Nobody does that, right? Even a kid as simple as a kindergarten kid is able to figure that out. Why? And because they have something fit in their brain through videos, through books, through parents teaching, whatever, that is what I call as supervised data. There is a trained data in their head. They have that answer somehow. If you ask them explain, or you explain how to define an apple, a rule-based engine like formulas and say like this shape, this size, this color, it's very hard to explain. But if an apple is shown, you'll magically say apple, no problem, right? So that is a trained information which is put in your head. You have the answer, you have the trained data. That means supervised learning. Got it? So that's what supervised learning. To truly understand it, we have to see what the other side is. Let's do the same example. This time we are not going to call the kids, let them have their own fun. This time we are going to call in aliens from other planet. We're going to call in aliens to help us with this. I'm making two assumptions. I'm making assumptions. Aliens do not have fruits. Lucky us, right? They don't have fruits. That's one. And the second assumption I'm making, they are not colorblind. So they can see colors, right? They don't know fruits, but they still can see colors. Those are two assumptions which I'm making. With those assumptions in mind, the aliens come in, they're given this problem, and they work on it, and they do this. They end up doing this. They find all the red things. Grapes and apples and capsicum, whatever, bell pepper, all of that. And all this green stuff, right? It's not correct. It's not what we were thinking, the definition of our answer, but it's useful. It's still useful. They do not have the trained data. Nobody taught them, right? This is apple, this is banana, this is thing. Nobody hasn't made the assumption. They don't have it. So they don't understand. When you don't have the trained data, that is called unsupervised learning. You're observing and making some determination. That's it. It's an observation fact. So keep these words in mind. I'm just giving you answers. I'm going to look for that back and see how much you're paying attention. So that's what supervised, unsupervised learning is. Making sense? Is it making sense? Simple examples. I know there are flaws into these kind of things. There's not flaws, but I think it's very high level generic, but it's very powerful to keep it in mind and take home. So that's the first part. Yes. Go ahead.
So unsupervised learning also from types of developing a model and all, it also requires your human intervention, right?
So the question was like, does it supervised learning use human intervention? Depending on what is human intervention we are talking about, I mean, right now, mostly everything needs human intervention. If you're talking about the programming part of it, but that's not the determination factor. Like I may have given the SPAM example, which was more in talking about when human interaction is there, then it is supervised. No, it's not. Nothing to do with that. Yeah, it's not that. I think as I talk more examples, it will get clear. If it's not, please bring that question again.
One more example, assumption you did for the aliens, that you assume that they have a neural networks in their brain.
Okay, there's another assumption I made it. So probably. So basically segregating that, I think that they should have the logical thinking part of it. Absolutely true. Sorry.
Yeah, let's say there is certain rules that we need to pick up. Would that come under supervised learning? Like, I mean, you see what
I know what you're saying. So is the rule-based kind of definition come in supervised learning? Actually not. A rule-based learning is very much a regular traditional programming. Like you say this, and that's what is happening. Every time if this happens, this is this. That's more of regular programming and not machine learning. So it's not, we're not trying to be a rule-based. We are trying to put some rules, but then we are learning through the different scenarios which we have never seen. We have never seen the data. That's what we're trying to accept. That's the key difference which we have.
Right. And a related question. Can this machine learning system, can rules be applied to predetermined rules? Be applied to machine learning before they are trained with data?
So can rule-based engine be applied? Absolutely. The real problems are not like very straightforward, this happens and everything. There is combinations of you apply some rules, you do some segregation, and then let it do. It's combination. We'll take some use cases and it will probably become more clear. Sorry. Okay. So now let's move to the next part. So far what we have done is supervised learning, unsupervised learning. Question, go ahead.
So the question on supervised and unsupervised learning is that you have, in supervised learning, you do have the prior data, whereas in unsupervised, you do not have any prior data.
It's more of rather than prior data, it's more about answers which I have.
Prior intelligent data.
Prior intelligent data, prior answers are available. So think about this as, supervised is we have the answer, we know it for some set of data. New data, if you know it, then you are probably a predictor better, you know everything in the world, which is not going to happen. We don't have a crystal ball, but we know sufficient amount of data which we know the answers. Think about unsupervised as observations. Just think about observation. It will make life much easier. So let's move forward. I think the second iteration will help us solve further on it. Then this is the same thing written in words. I just made it pictures, so it's the same thing. The aliens could have done a few more variations. They could have said red and small size, red and big size, all of that, but you get the point, right? Then now I'm going to go to the next level from supervised to unsupervised to a whole next level. I'm not going to algorithms right now because that's what scares and that's where it's confusing. That's where the math comes in. We'll go there, but not right now immediately. I think this is more of a systematic approach. It really helps everybody understand, and that's my goal. So the next level is there are three kinds of techniques, which we call as classification, clustering, and regression. If you notice, the first initials have made it red. I used to teach kids. So there are memory techniques which you have to keep in mind. So that's why I'm going to ask you to remember CCR. So abbreviation CCR stands for classification and regression. When I start talking, I'm not joking again, and I said like you are trying to talk. So this is very important. I want you to remember that very well, and that's why I put this acronym CCR, which stands for classification and regression. So these are three main buckets of techniques in the holy grail of these things. This is the big picture. I think that takes care of most of the things. So we are going to take some time in each of them and understand each of them at that level. Only hint which I'll pass it right now, clustering is the only one to unsupervised. Just remember that hint for now. I'm going to give a lot of hints because I want you to pass and me pass right together. So clustering means unsupervised. Remember that. You will remember. I know that. Now let's go one by one. So classification, the literal meaning classify means to put in some kind of bucket, some kind of group, as simple as that, right? And how it does, it goes through something called as a decision tree model. It takes a decision tree. Most of you have seen some flow chart, something like that. This happens, then yes, do this, yes, no, do this kind of a thing. So this is a similar model taken or car mileage prediction. If the vehicle weight is heavy, yes, then it's high mileage. If no, then ask for more questions and keep going and keep going. End of the day, you get some buckets. And you say, final outcome, that car is high mileage or low mileage. Right now, there are two groups. It doesn't have to be two. It can be three. It can be four. It can be, say, high, medium, low, very low. It's all fine, right? It's just taking some decision points. In some form, it is actually a rule, if you think. If you are putting some rules and you're saying condition. This is very simple. You can write an if program and you're done. Right? It's a little more than that when you start doing humongous amount of data and everything, but at a high level, it is about taking some decisions and going through that. And end of the day, we want this group or this group. That's it. That's what we are trying to do. Next, clustering. Whenever unsupervised, I told you clustering is the only unsupervised. Whenever I'm bringing unsupervised, I'm calling aliens, right? It's also a good memory technique. So clustering means aliens. So aliens came to the planet and they just started observing. And they just saw two kinds of patterns. One, there are things which are brown and run away, right? Depending on, and they classify that as animals. And depending on what kind of animal, if it is a lion, it's running towards you. If it's a deer, probably running away you. But they ran away, right? Some form of shape. Then there are things which are green and they don't run away. They just, if you cut them, you do anything to them, poor thing, they're going to be right there. So that's what they observed and they found out animals and plants. Making sense? So they just observed. Nobody taught them this is animal, this is planet. They just came in and saw some attributes and based on that, they made observation. That's why the word unsupervised, aliens, observation. Just keep that in mind, the triangle, and you'll be fine, right? I'm just giving you a few hints to that. That's what clustering is. Third one in the list. If you want, you can close it. I think, yeah. The third one is regression. So this is a good example of regression. This is about if you had kids or have kids, the first 2 years of your kid's life, you have been showed this over and over and over and again, right? After that, nobody cares, right? The first 2 years of the kids, we continuously keep on going to the doctor every week initially, then months, and then never, or once in a year, then it becomes, right? The first 2 years, they go to the doctor. What happens? The doctor takes all these kind of measurements, the circumference of the head, the weight, the height, this, that, all of kind of measurements, and then they plot They plot and give you this chart, and you look at it very eagerly. That kid, what's going to happen? Then you start feeding him more or less, depending on what is happening, right? What they're doing is they're predicting the weight of your kid. They just have the data for a few years, in the first 2 years probably, but they're taking the data and just extrapolating it based on the other people in US they're looking at, and they're looking for the curve and saying, oh, there's a 50% chance this kid is going to be 70 kgs or 150 so-and-so pounds at this age. So they're predicting some values based on that. And then you look at it, you get scared and everything, and especially if you are Asian, you will never be on this chart. You'll be somewhere in the bottom. Most of the things, this chart doesn't apply to you. Don't worry about it. But we do worry, right? Then we come back home and say, we are going to buy so many things, and our kids should eat organic and all of that fun. That was on a lighter note. The thing to remember, regression is the only technique which tells you absolute number. It says 56 kgs, 72 pounds, right? So-and-so height. It is telling you exact thing. This much age, right? It's not telling you heavy or low, light. It's not telling you that. Regression is the only technique which is predicting a value, a number, right? Other two techniques were doing what? High mileage, low mileage, animal, plants, right? So that's a huge difference when you think about regression. It's a value, right? I'll need all those inputs when you can say, let's see how many of you catch that when it really comes to solving the problems. So that's a very high level of CCR. What we have done so far is simple things. Supervised, unsupervised, right? We did CCR, which stands for clustering, regression, perfect. So people are doing good. Then comes the confusing part. That's where everything gets blurred. Like lots of algorithms, it starts talking about random forest, logistic regression. We know black forest, it's a good cake. What is this random forest, right? You all don't know all of that. So I'm not going to bother you guys with those things. That's what we lose people. But I'm going to give you a technique. I'm going to give you a technique which will solve the problem, and we will solve a problem together, and we'll try to see if we can together, with just this much knowledge and some more things which I'm going to give you, we are going to work and solve a problem or not. So to solve a problem, what is the problem? So first I need to paint that. So we start with a project which we did as a company. So let me explain you what is the project. So this is a very classic problem, right? Any company, business wants to know if their customers are happy or unhappy. Why? Why do they care? They can sell more products. Repeat business. Customers are important. Every business has some form or shape of customer. Otherwise, what's the business? You're a charity or something else. Even charities have customers. So, right? So referrals, any kind of thing, it's very, very important. And actually, it's a foundational bed data which you can use in many form or shape. If you go to a customer who's unhappy, with like this grumpy person out here, and he's pretty angry, and you go and tell him, like, please buy this other product from us. They'll say, forget it. I'm even thinking of returning this one. What are you even talking about the other one? Right? If you go and please ask and refer our friends and family, they're saying, nope, I'm not doing it. Right? That's not going to happen. So you need to understand the messaging. If you ask this person, probably he'll be, refer to this person and that person. He'll be willing to send your message some across. So understanding that messaging is very, very crucial for businesses to understand. At some points, you can convert this. What I have learned through my journey, or this particular project itself, I'll talk about that. So this was a hackathon for one of the clients, which we were there, and the client was doing a hackathon, a huge hackathon, and they asked us to, hackathon means what, 48 hours, 2 days, day, night you have, do whatever you want, sleep, don't sleep, it's your problem. They'll give you some coffee, food, Wi-Fi, that's it. That's what we need these days, right? And you do whatever, you come up with a solution, problem, and everything. So we took this problem, our data team took this problem and tried to solve this. And we came up this whiteboard. This is a little whiteboard from the picture of the whiteboard, which is thing. So first we thought the customers have to be listed down, and we need to come up with some scoring number mechanism, right? Otherwise, mathematically, how are you going to do it? So we came up with some logic to come that. And there are, by the way, many, many scores. We just don't have credit score. There's so many scores companies have about us. Our happiness scores, our satisfaction score, our affordability score. There's so many ones. We don't know. But they have it. So they have this kind of numbers to identify us, right? And what they do is they eventually try to get you into some sort of scoring mechanism. What we did, we went to the subject matter expert. This is the banking client, so it's good and everybody can relate to it. We took some parameters and we said, like, okay, what else different things are important to think about customers going to leave us or not leave us or happy or not. the subject matter expert gave us 43 different attributes. I said, I have only 48 hours. It's almost like spending an hour for one attribute. That's not happening. So let's shorten it there. This is a hackathon, just a starting point. So we took 5 attributes. I'm just going to explain 1 or 2 to you. The first one we took is the login or check-in. How much the customer is engaging with you. If he's logging to the website, going to a branch, or doing anything on the smartphone, any kind of touch point which he's doing is good. The more frequent he's doing once in a week, he has done it. Then he's having more interactivity engagement, right? If he's not touched it for 6 months plus, probably he's gone to another bank. He's more loyal to that bank or thinking of closing this account. Very common. So that's kind of a very basic rule-based thought process. And based on these, the points were given and they score up to something, numbers, right? So that's just random some numbers. Then you add some logic and the machine defines like, okay, maybe below 50 and 50 is red. So it's risk, a customer at risk, unhappy customer, right? And then we came up with a traffic light signal like red, yellow, orange, whatever, and that green kind of indicator. This number and this indicator is useless. Just this information, you cannot do anything. If you go to a CEO and say, half of your customers are going to leave, he's only going to panic, right? He can't do anything. You just said like, okay, you made him frustrated, angry, and panicked. But what can you do? The real magic is this, right? Okay, this customer is unhappy. We think these are 5 things you can do about it, right? That's the recommendation action which can be taken. Maybe he needs more training, better understanding of the product, maybe better customer service. He doesn't have an ATM near his house. You have to balance that kind of a thing. There are so many things in banking which I learned through this exercise. There could be all of those kind of things, right? So that's the powerful thing, which you have to churn that out. Otherwise, you're just making people panic. If it is a customer who's happy, he can suggest you can sell more products, which is cross sale. You can easily suggest more products. Oh, buy loans from us. Do this thing from us, right? To the bank. All that can happen. So that's what the basic logic is. I'm not going to go into details of all those points. The learning which had big learning. So we luckily had finished. So they did every site or every branch. They did this competition. We were third. So they took the first 3 in every branch and then did the final. In the second round, we improvised. I went to the customers and started talking to the customers. And there are some really good, insightful things which I learned from the customers. Our first project, actually, this name is still now, it says customer retention. Retention means trying to preserve your unhappy customers. I said, nope, I'm not interested. I'm not interested in this guy, actually. It is said like customer is right always and customer is to be preserved. No, in the real reality of the things, this guy is more important. So change your problem. Change your problem to a bigger thing, customer engagement. So we changed it. We made it customer engagement. Why I say it? Because once a person is unhappy or grumpy for whatever reasons, utmost effort will only save him. And the chances are very low chances that you will be able to save somebody who is already gone in that mindset. Even if you're successful, you have to put double the energy, double the effort and all of that, and you'll get 1% left. He's not going to refer most of the time. He's not going to. This is unlimited gain. Here I saved from my chance of saving 0 order to 1 order. Here it is from 1 which is sure to infinite. He can go crazy with us. He can come as an ambassador. He can go for different referrals. He can buy more products. So that's where my focus should be there. That was insightful for me. Wow, that's the way to look at it. As a business person, I said, you make sense. Let's go with that model. And we changed our approach and brought on that thing. Luckily, throughout all the sites, we were second. We bumped up. And others were like, okay, we are done. We're going to show the same thing the next final round. We didn't do that. We learned from that. There are several things which we learned. Now, this is the banking client. The architecture-wise, data comes from a lot of places, brick and mortar, ATMs, digital information, because most of the people are moving to phones, and we have great features like you can deposit your check by phones and all things. So digital data, all of that is brought into something called as a data lake these days. So it's a single place of putting all the data together. So you can build pipes and drink it, put your faucet taps into that. So it's a kind of a concept. There's nothing technology. There's no technology behind it. It's just a concept. So you put all this data into one place, put some machine learning, some logic onto it, and then churn out that unhappy and happy kind of a thing, and then do several things. This was another thing which the customers asked. We want engagement meter. Give us a score and a kind of a visual way of it. This was another one which they have say info dashboard. So if you go to a branch, typically what happens, they ask you to swipe your debit card. If you notice, if you go to teller, they will ask. And they immediately start looking at the screen after that, because after that, once you've started, they know a lot about you. They know how much money you have, what kind of customers, what complaints you did, what everything they know, literally. They know a lot. And that's why they want you to swipe and understand it. In fact, nowadays, that's even not needed. At the same time, we were working something called technology called Beacon. So when you want, if you have an app and you've enabled that, or even a smartwatch app for that matter, you walk in a branch, automatically they will know, oh, the CEO of so-and-so company has come in, please pay attention, or this guy has come in who doesn't have $100 in his account, don't care about him. Right? They don't do that. I'm just saying that technology does exist. This has also been used in retail somewhat effectively, but not so much. Let's say you are in a Gap store and you've gotten the kids location and you have that enabled, it will send you coupons for kids apparel at that point of time. So that capability technology does exist. So that was something the clients mentioned. They built into that. And once that information is taken in, it can be fit into any kind of platform, whether it is the teller looking at it, or you getting an alert, please refer friends and family if you are a happy customer on your mobile, or any format. And once the data is there, you can use it any form and shape you want, right? That's kind of the high level it was. This is some under the hood. We worked with the data scientists, and this project was taken and became an initiative, and overall data initiative, which a lot of projects were built after that on top of this data. So with that said, I'm going to ask you guys, now is the time which you guys are going to help really solve this problem. What is the problem? To solve any problem, first we need to understand the problem. What is the problem we're trying to solve for this customer?
Whether the customer is happy or not.
Well, the problem is customer happy or unhappy? Good? Agree. Or not agree, that's fine too, but I think we have to come on the same page. Otherwise, we are solving different problems. That's not good.
The problem is to figure out how to keep the happy customer.
That is a problem. The first you answered already completely. Done. You done. You don't know. That's what happens when you keep on poking people, then they go on the wrong answers. Your first answer is perfect. So simple, right? We're just saying happy, unhappy. That's it. That's what we're trying to solve, right? If you tell the customer, he will do whatever he wants to build on top of it. There are many applications, many use cases. You can build a marketing campaign on it. You can do a service better campaign on. So many things can be done. I've seen several projects. At least 3 projects I've worked in this kind of initiative because there's high tech, banking, customer is always there, right? So everybody's clear. That's our problem to solve. Now I have taught you very few things, right? Supervise, unsupervised, right? Everybody remember the alien, right? Everybody remember the CCR, yeah? R stands for regression is good at that. Actually, I taught a lot to you. I mean, you don't believe, but I think once we start going to that, we have got a lot of powerful things which we can use and do that with one more piece of information. So I'm going to give you a cheat sheet, right? There is a cheat sheet which many companies have given and Microsoft also has provided. I like this one, and Microsoft has now removed this cheat sheet and created a new one, which is a messed up one. This is a much nicer one. I'll share this with you folks. This is a nice little cheat sheet which they have, and this helps us to really navigate to the path and go through this whole cycle. So we'll use this and your prior knowledge, right? This is not useful if you don't have any knowledge. So it helps to a certain degree. When I looked at this sheet first time and I was doing this CCR thing, I said, wow, that maps in so well. So I told you CCR. What is CCR? Classification, right? See, if you look on this right side, it's all classification, whether it is 2-class, high, low, or multi-class, high, low, medium, very low. It doesn't matter. It's all classification. This whole side is classification. Then we said second C is for clustering. That's where it is. So this clustering hanging out here. And finally, this is a regression.
It's not showing up there.
What's going on? It's not showing? I think it's back something. I'm showing on regression. So yeah, it's a color background thing, I think. So regression. So, but it fits in pretty well. The CCR fits in pretty well. I did not teach you anomaly. There is one other technique, anomaly. It's anomaly, right? We can leave it aside for now. So I taught you most of it, so CCR. Now let's use this and your help with all the hints and information which we give. Let's take it back now. So we will try to solve this problem using this. We know the problem, everybody understands it. We'll use the cheat sheet and start solving the problem from the start point. We go to the start point, we go to the first question. First question we are asking. Are we predicting something about future data points? Are we trying to predict something about somebody, something? Yes or no?
Yes.
Yeah? Yes. So most of us agree. This is a little bit, people get confused a little bit. I think I'm getting a lot of yeses, which is good, which is right. So we are predicting. We are going in there. As soon as we are predicting, you're out of clustering. The aliens are not needed. Get out. We are not observing. We are predicting here. We are going to say, basically, new customers, we'll do something. And with new customers, when they come in, they sign in, we can say, oh, he's going to be an unhappy customer. Just he signed in. We know it. Because this patterns which we are saying, kind of a thing, which behavior. So that's what we are doing. So we are predicting. What are we predicting? Are we predicting categories or values? Categories, right? So it's category. There is an inline underneath one. So, but for now, that's why I rephrased the problem very clearly. Wanted everybody to be on the same page. So happy, unhappy, right? So there's a category. So we move this part. We move to categories. So we go to the classification. How many categories? Yeah? Two? Do you agree? Yeah? So happy and happy. So we move to the two-class classification. So that's where we landed. So we have, with just this knowledge, with just 1 hour last, I mean, some of you may have been knowing machine learning, some of you don't. But within half an hour or 1 hour, we went through the cycle and we have reached to a point that we are able to reach to this point, which is great, actually. That's like 60% or 70% of the data scientists. That's what it is. That's getting to that point. Or you have reached to the status of what I call as weatherman. You have reached to the point of a weatherman, which you can predict things. Will it be perfect? That's not sure. And that's where it starts going to more next level. But it's a good point. I think most of you did good. I think thanks for participating and everything. So, but that's a good, simple way of putting together how we can map through it using a cheat sheet. What I did not do is go through these algorithms, which one to pick right now. And that needs a little more knowledge, of course, rather than spending an hour. That's a little more, right? And it's lots of determination. The good news is, actually, you pick any of them, you'll be almost right. The question is how much right? That's the question. But you'll be right most of the time, right? And it starts depending on various things, like accuracy versus speed. And there are two contradictory things. Let's say I give you a problem to solve, okay? I give you a 5-digit by 5-digit multiplication, and I give you only, let's say, 30 seconds, or 10 seconds for that matter. How many of you will right? Most of you are not going to be right. Even if you try to use the calculator, it will take a few seconds, right? So you'll not be right. If I give you 5-digit to 5, I give you very little time. Let's say I give you the same one, 5-digit to 5-digit multiplication, and I give you an hour. Use calculator. How many of you are going to be right? Most of you are going to be right. That's a dilemma between speed and accuracy. There are life situations where you have to take decisions like this. And accuracy is okay to flawed. That's fine. I just want to move forward. I want to make a thing. I want to go to this restaurant, this restaurant. You're not going to die if you go to that other restaurant, right? It's just quick decision. You just made it and moved on. The accuracy is not important. When you're doing a heart surgery, you better be right? At least try to be right as much as you can be, right? So that's where accuracy is way, way, way important. So depending on your problem, things change. The things change. And that's why this speed versus accuracy can become a factor. So there are several of those things which start coming into factor. But this so far at a very high level, what it gives you the understanding of doing supervised, unsupervised, CCR, and navigating and thinking the mindset to see a problem. How do I navigate and come to this point? I want to stay with that. Is that making sense? Everybody on the same page so far? Yeah. We're not going to go to the algorithms. I hope you understand that there are hundreds of algorithms, and if you go each of them, the door will be open and soon I will see exits. We don't want that. So that's a quick so far about the concepts. Thanks for doing that. Let's move into the demos. Have any questions meanwhile? Go ahead.
So this seems like a very generic flow. So are all each providers, do they have their own algorithm cheat sheet, or they all follow this?
Good question.
The algorithms themselves are different.
Yeah.
From provider to provider.
So let me rephrase for people on the phone. Is this cheat only applicable for Azure? No. Actually, I should cut it off from the top, and it doesn't matter. Anywhere you take it, it's same. Everybody has the CCR thing going on, everything. There are many more algorithms, but it has a good, robust list. Algorithms. People start, maybe it's all about creativity. There are two guys sitting in Google, they may say, oh, let's try to improve a little bit of that, and there is another variation. This will keep coming, but they're not like thousands. We're talking hundreds of those variations. Cheat sheet can be applied. This you can take anywhere, it doesn't matter. Yes.
So the first part that you described about the problem, customer retention, that falls under BI and decision science space. And when you spoke about prediction, that falls in MI space. Is it correct?
ML space, yes,
ML.
correct. That's correct. So there is a part which you are just observing the customer, and then you are predicting that. So there is part of the data analyst or BI, business intelligence space, which you're saying, and absolutely there is a prediction part based on that.
And most of the prediction falls under machine learning?
Almost everything. Everything in the prediction. Prediction means machine learning.
Well,
Pretty much.
nowadays, previously there was statistical models on.
The various of the names we are
Like
talking.
the example you gave about chatbot, those was the statistical analysis. So
Currently, and
there's some fine line.
right, but these are definitions or acronyms we're talking. What she meant is like the prediction engine. Yes,
Yeah.
that's kind of a thing. The names people are use change. Yeah. Yes. Any other questions?
Typically, if you follow the same example, if you come to classification, now we talked about speed versus accuracy, right? So each of them have its own merits and demerits.
True.
So how do you determine which way to go? So you would need probably the the employer or the bank, for the example, their input. How do they see it, or how do you go about going which way?
So, I mean, the question, just rephrasing another way, how do we really go and identify those algorithms and everything? So that's the job of the data scientist. The data scientist's job is a pretty complicated job. I think I have written a blog. There are 5 hats a data scientist wears. There are a lot of people have interests or ambitions to become data scientists. I trying to warn the people for valid reasons because it's a journey. I mean, they think like they go to a program and they say, I have to pay 10,000, 15,000, I should become a data scientist in 2 months. They say, okay, that's not happening. You're in trouble. And then they come back and say, I did not get a job. I said, who told you that you should get a job just because you paid 10,000 and did a course for 2 weeks or 2 months? Sorry, how is it going to happen? It's not practical because a data scientist needs a lot of different skills. And that's what's going to help solve these things. Number one, he has to have all the data skills, how to clean data, map data, munch data, understand data, all of that capability. Basically, all the big data knowledge as a big data person, because most of the data could become bigger ones. Second, he or she needs subject expertise. If for banking, I was not expert. I had to go to that person to really find, and he gave me a big list. I didn't like it, and probably I'm wrong. He is more right. The subject matter expertise plays a very important. I can go and just say, okay, I'm going to do fraud analytics because I know math. No, it's not going to work. You need the domain expertise. That's second one. Third is mathematical skills. Math, statistics. Most of these things I have been avoiding it for this short conversation. This is good to get you started because I don't want to move you forward rather than repel you. But you need it eventually. So statistic, mathematical background is needed. Fourth, he has to be a good communicator because all this is jargon. I mean, this is so much of jargon, math, and formula and everything. If you go finally, you have to influence your decision maker, the C-staff, your investors. They don't know anything. They're too busy. They're not going to get in your math and formula and give you look at your tables and Z-scores. They're not going to do that. Tell them in a very concise way, but cover all the aspects and say that. So you have to be a very effective communicator, right? And then you have to be like a general catch-all person who can have the flexibility to do all these circus. So that's a lot, is the thing. And combination of all those things really help it. So can I say an answer? Like, okay, this is the way to go and everything? No, there is no. There is fine-tuning and dialing because your subject matter experts, your mathematical answer, it didn't work. It go up, go down. Just keep on doing it. Then you get as close as possible. That's why they are paid the big dollars.
So it can always happen that you go one road and maybe you realize it's not the right thing. Come back.
It is. It will be multiple routes. People will say, 2-class SVM, let's try it and let's see the accuracy of it. Let's see the different features and there are different ways to look at it. I'm not bringing all the jargon right now. But check, it didn't work. It is not working. Let's do another one. And keep on iteratively doing it. Yes.
That's the difference between scientists and engineers. So living in Bay Area for a number of years, there are very few smart mathematicians and the statistician who can look at the data and analyze it and give you very effective answer. Most of them are, you see million people working in Bay Area, they're all engineers. They do trial and error and something that figure it out.
In fact, what he's pointing out, there is a Venn diagram. I should bring that as well. There is a Venn diagram where math, machine learning, and domain is brought in. So wherever you are coming in from there are very few true data scientists. There are people who have come from this area, I think, but I call that as a journey, right? People are going through the journey. I think it takes a lot I mean, you cannot just switch something and say, oh, I have all these expertise. You need a journey. And that's why I deter people from thinking and putting that ambition. I'm not saying don't do it, but be aware that it takes a while. Don't try to just commit suicide and say, oh, 2 months, I will be this. And then they get panicked and angry and frustrated, and some had anxiety attacks. It does happen, right? All of that. So good questions. I think the things. Let's. Any questions? Okay. So let's move to the demo. Before we jump into the demo, I'm going to bring in a few more slides and take more of your quiz to check out whether you're really paying attention, right? So there is some interesting sites to really showcase what machine learning is doing. And this is a site which you can Google it yourself, howold.net. This site is actually taking images and will predict the age. So for fun, let's try to do that. I've been told to avoid ladies' pictures. That's not polite to ask ladies' age. So I'm going to deter away from that. I was doing a conference and I took one of the images and saying, that's not polite. I said, okay, I'm not thinking from that side. So let's guess it. What do you guys think? Let's see who comes the most closest. 42. Okay. It did it probably. Sorry? 50? Okay.
45. 52.
52. Poor guys are really killing. So let's try to forget the lady. I think let's do the kid and the man, just to be keeping the social norms there. So how much is the kid and how much is the dad probably? 2. And the man?
30.
Start becoming smarter. You started giving ranges now, right? Sorry?
1 year and 28.
How much do you think? Like, how old is this kid?
3.
And? Okay, we'll go with him. And 28, so he's close. He's pretty close. See, I told you, right? So that's actually you can put your photo. Use your own photo, and you can try that. Is it going to be correct? Not always, right? Maybe it's an algorithm. It's just looking for some data points and everything. I'll tell you what will happen. If you're wearing glasses or something, it is going to show age. Exactly, and that's why I did the LASIK surgery. What do you think so, right? And if you are having facial hairs, it will show age. And it's going to use all those data points. That's nothing magical about it. So it will do those things. So it's not going to be accurate. It comes close, but it's an interesting problem. You take images and give it and anything. Now you tell me, out of the CCR, what is this going on? Which one is this? Good. You're thinking now, right? Because it's exactly which you're predicting. Good job. See? So that's kind of the problem which you're doing. So this is one site, and there is another one. Some people don't like age to be called out. So that's why there is another one called whatdog.net. So if you don't know which this dog is, from how you find it, I think I'm not good at that as well. But you can identify, you can put your dog's or any dog's image and try to find that type of this. So we'll take 1 or 2 of them. And what dog is this? Sorry?
It's not hot dog.
Okay. It's not hot dog. Okay, got it. Anybody dog? Pet? Okay. Got it. Okay. So that's another site. This one is doing what? Classification. So it's taking the data point and classifying it based on all those different multi-class classification. So that's what is happening. So we are turning all this data, and these different interesting sites have been built on thing. The site looks fancy and everything, but behind scene, when you think about the raw level of it, what is it? The input is images, and then you are doing some kind of model on that data. Some points are taken and some data points, as I say, the glasses and facial hairs, all of that, wrinkles, all of that is taken into consideration, and some of the historical knowledge which it has, it is built on that and predicting some answer, right? What you build on top of it is your imagination. You can build a website, you can build an app, you can do some interesting stuff. It's all about how you do it. An alerting system, somebody asks questions, somebody is getting the answer. You can build whatever you want. But the real raw math is take some input data, churn it, and get some outputs out of it. That's what these sites are doing. So pretty good. How are we doing in terms of time? It's good. Okay, so what I'm going to do is I'm going to move to the next stage where I'm going to go try to do a demo using this Azure's machine learning offering. The reason which I picked this one is, as I said before, in a short, quick demo without doing much coding and confusing people, this is pretty good and easy to use it. What also Microsoft is trying to do is really put it in such a enticing and easy way so that everybody can buy and take it and use it for lots of usage. So if I'm just clicked on the pricing part of it, it's free. Doesn't even need you Azure subscription. There is something called as Azure Cloud subscription you have to take for most of the other things except for this. And you can do up to 100 modules. A module, I'll show what it is. It's a one block within the whole program. I'm going to do something with 8 blocks and solve a problem. So a lot of which is free. Even the paid option is just $10 per seat per month. That's cheap. That's quite, for a company, $10 per month per person is nothing. Software are sold much expensive prices. If you know you have been in the industry, you know that. So the whole point is they're trying to beat their biggest competitor, who is right. So that's what they're trying to do. So that's what is happening. So that they're trying to do that, and you can have lots of tutorials, things if you want to take this conversation forward and build onto it. I would say typically this is a good starting point, and then you can take your model somewhere else. Right? That's what I think. It's transportable. It is which you can port it. So now I'm going to get into this and get going with this. So once I've logged in, so once you log in and I have an account and I have logged into that account and signed in and all of that stuff, and I've already kept it ready. Hopefully, it might ask me to do it again. No, it's good. So we do a demo and create a model using some basic information and walk through that, what's happening to that thing. So once you log in and you create an account, it's a free account, you create an account, you enter into something called as Microsoft Azure Machine Learning Studio. It's a studio, it's a canvas where you drag and drop things and create a model, which will help you to predict certain values and certain things. So we're going to do that. Then everything is an experiment. That's Microsoft terminology. That's not general terminology. That's Microsoft terminology. You're creating an experiment trying to do something. It's a small project, experiment, hypothesis, whatever you call. That's what we are doing. So I'm going to start with a new one. So when I click on it, I'm going to the steps which I'm going to walk through it and slowly, steadily build onto it. The first step which is we are going to go to a new one. We are going to create a blank, create in the experiment section and create a blank one. You can name it anything what you want. I think you give a name for this canvas and you can define it. This is something called for the income prediction. We are predicting the income of people, basically. We are saying this problem is specifically saying a person is about 50K salary or income or less. That's what it's trying to find, right? This is a very common problem. And how many of you get private jet flyers at your home? Not even absorbed it probably, or they said enough.
There's a club.
There is a, how many of you get it? Rarely, right? There are very few, right? Which really get it, right? Why? Why do we get those Chipotle and the Subway and the Home Depot flyers? Why don't we get these? Exactly. This demographic, living in this bracket, this club membership, all of that matters a lot. Somebody has done this math on you, and that's why you're not getting it. As simple as that. So this is pretty common. So all this marketing, they don't have unlimited budget. They want to send a nice little booklet to somebody who's just going to use it and give it to his kids to do painting, right? They want to value that because nobody has unlimited budget to do marketing. So that's what they control that. And they find to see the best candidate who I'm sending, they will use it or not use it. That's what the whole point is. So they do that. So we are trying to do similar. Here it is only 50K. The same problem can be taken for 5 million per income, right? And then you, depending on what you're sending, I mean, 50K, then you say, okay, send him Subway burgers. That's fine. So you can take the same problem. So it's a very useful problem. So now,
Credit card companies use that.
Credit card companies use that. Exactly. So the different kinds of credit cards, which think black cards and all of those things will be different category. Absolutely. Many places this is used. Club membership and so on and so forth. So what this is going to do, we're going to take a 32,000 individual data set and go through that. This is just taking a sample data set. So what Azure has done on the side, which you have a panel where you can keep taking these blocks and inputs from there. And this is like pre-made data of 32,000 something records. And it actually has the incomes already provided to us, which means what kind of learning is this? He's the only one answering. My prediction came true. He's beating you guys down, up, down, right. It's exactly funny because we have the answer, we have the predictions. Now, one thing I didn't teach you, I mean, I left it for this point. In a learning model, what you do, you break your data into two parts. There is something, you split your data, it's called as learning set, training set, and then you call it a test set. So what I do, let's say I have this 100% of these records, I'll take 60% of this record, build a model based on that, build a formula based on that, and then I will try formula for the remaining 40% and see whether my formula is working or not, my model is working or not. Is that making sense? Right? Why don't I just try and just model based on that?
Nothing to test.
Well, I test. How will I make sure that my model is right? It's like I'm just guessing then, right? I want to guess. So that's why they break into two parts. Either it is, I mean, the number doesn't matter how much it is. It's usually 60-40, 70-30, 80-20. They keeps on playing. That's what the fine tuning and dialing is. I'll play with this model, that kind of a thing, which data I'm training based on that. So let's say I train my whole model based on all the people who are 5 million and above income. And then I'm trying on somebody who is like jobless. Is it no? You trained on the wrong thing. Right? Machine is not going to magically know. It's based on what you train. So what set of data which you train, did you give a good, nice subset of all the categories and all of that? That matters. So we split the data in two parts. Here we are going to do 70-30. What Azure is going to do is first of its machine learning ML from Azure is going to try to do, that is the block, which is called a split data. I pick that drop, bring it here, I say 0.7, which means like I'm going to divide 70-30, and that's some random seed, some errors if you want to say, I don't want this sample data, this test data, I don't want it. Those are side things, don't worry about that. This machine learning algorithm, this was what we were doing the first half, right? So that was the knowledge of the data scientist, which algorithm to use. We used our knowledge of supervised, unsupervised, CCR, and a cheat sheet, and we came up with some decision, right? This is the algorithm. Usually a data scientist will try, and I think maybe this is his try, and they pick up some algorithm. Now, in this problem, what are we trying to do? We are saying the person is above 50K or below. What kind of thing it is, right? We're not saying exactly 57,000 so-and-so. We're not talking about that. We're saying up or low. That's it, right? So that's what it's saying. So it is a classification problem, and most of the classifications are some kind of decision tree. Let's say we pick this one, 2 class, and there's 2 values. So it's a 2 class. 2 class boosted decision tree. That's the algorithm which we take. Our data scientist told, or we use the cheat sheet. However, we came to that. Now we're going to use that. We go to this again panel and we say search that algorithm. Find that wherever it is, all these algorithms are written down. I'm going to drag and drop and keep it there. Now, I'm going to based on that. I'm going to use that training data, train the model based on this algorithm and split of my data. And now I'm going to create a new field, which is called as income. It should be called as a predicted income. This income is already there. I'm predicting a new value. Now we're going to try our model. We have given 70% of the data. Let the model build it. I'm now going to give it as another score the model. So I have another block called score the model, evaluate the model, which is going to test it after scoring whether it is sitting on my 30% data and see if that is right or not, which is its finding or not. So we are going to do that experiment. This is it. That's it, done. These are called the modules 1, 2, 3, 6. I just use 6 blocks and that's it. I didn't write any code, right? I didn't use any programming anywhere, all of that, yes.
Those models evaluate and all those things are already there or you created?
There. So all the panel things on the left side panel, it was all there. Nothing which I've created. Let me finish the flow and then we'll open up for questions. So last step is running things. So we run this thing. We just go through that. It's a drag and drop again. So we just go and click on this button, which is there. It's going to take a few seconds. It's saying queued at this point of time. It's not a huge set. 32,000 is less for this kind of data size. So then we can visualize and see, oh, this was the real income and what our answer is saying. And what's the probability? right? Because we're never always going to say this is right or this is wrong. We're saying this much percentage of chance or not. So we say that, and it typically, I'm now going to a little bit of jargon, it results in these 4 things: true positive, true negative, false positive, and false negative. Meaning I said this person is above 50K and he happens to be that is true positive. I said yes, and it resulted. If that person was not, that is true negative. What you want is true. What you want is all your numbers should be sitting at true positive and true negative. The more, when I say the person is 50K above, he should be 50K above. When I say no, that person is not, it should not be there. So that's my goal. And that's why the fine tuning and dialing keeps on coming and refining. I'll change, okay, next time, let me try 65-35 data, 60-40. I'll use the different algorithm. I'll keep playing and trying to find where the right model is there, and then we'll productionalize it and move into production environment. So that's kind of a very fast and quick demo, but I think I didn't create all of these. All of these things are already existing. I have leveraged whatever thing without writing a single piece of code, without much knowledge. And I think hopefully most of the people got a sense of what it was happening, right? So this model then typically in a production kind of environment, these are taken out. Once you are happy with this is taken out, and then it's productionalized using maybe Spark machine learning or something. It is okay. You can do that. They are all convertible formats. And you can export that into PMMI model. There are some models which you can do that and then move to other exercise. So in terms of content, so now I can open other things. So let me quickly summarize what we were trying to do. As we said in the first part, we were just trying to break into 2 parts, very basic concepts, right? Very, very basic concepts. I think I usually sometimes, I today did not say, but I usually say, bring a 10th grader to me and I think he will pick it up. Somebody really brought it today. Maybe they were testing, but he did pretty good. So that was our concepts. We went through a small exercise and tried to solve it, which all of you participated. We got that understanding, just to get a sense, like how does this thinking work? How does mindset work? And then we took some examples in terms of the real problem, which we happy and happy customers. We took some examples of age and different scenarios kind of things. That's kind of in terms of content which we were trying to do. Thank you for participating. I'll take any questions, but really appreciate your time, and hopefully with all the hassles, other things, the WebEx and the chairs and everything, but hopefully the content was worth spending your hour too.
Good job.
Thank you. And thank you for all participating and really answering that and doing it and being successful.